All right, I think we are rolling. And for my Timescale team, can you hear me all right? Does the sound okay? Can everyone hear me? Awesome. Okay. Oh, sweet. Thank you, Jill and Ryan. Looks like we are live. Cool, cool. So, welcome. Today we are going to be analyzing NFL data using Timescale and Postgres functionality. So, get pumped. I'll just go on and roll with it. So, let's talk about the agenda. So I'm going to do a quick introduction just to kind of talk about the data, right? Because part of analyzing data, an important part of analyzing data is understanding it, right? Trying to figure out how do the tables connect with one another, what columns are important, or how can we join and things like that. So we're going to kind of do that. So we do an introduction, understanding the data. And then we're just going to do a quick setup for the data analysis. And essentially that's going to be really just setting up a continuous aggregate, which is going to help our queries be far more efficient, which is going to be really crucial for, right, saving time in analysis, which is awesome, right? Anytime we can save time, that is a good thing. And then fourth, kind of the meat of the presentation, we're going to just really analyze the data together and try and figure out and understand some questions that we might have, and also encourage you guys, right? This is going to be just scratching the surface of the possibilities that you could do with this data set and any data set. So hopefully it will just kind of get you guys started, and then you can ask even more questions, dig in more with the data, and answer some really cool stuff and figure stuff out. So let's go to the introduction. So this NFL data set, we kind of stumbled upon it through Kaggle, which for people that may not be familiar with Kaggle, it is an awesome data analysis tool. It's like an online tool, and they have like hundreds of data sets. It's really cool. If you're interested in data science, they even have like tutorials on like how you can do some like machine learning stuff with Python and R. It's super cool. So highly recommend checking it out. But on Kaggle, there are also competitions. And the NFL decided to do a competition, their Big Data Bowl, and this is for their 2021 Big Data Bowl. They do this fairly often. And essentially, they made accessible tons of free NFL data. And it's like especially cool because so there's a tracking table, which I'm going to talk more about the tables and stuff when we are understanding the data. But the tracking table essentially is IoT. They put RFID chips into the players' uniforms and actually on the football as well. And so the tracking data is, I think it takes about 2 to 4 readings per second over every single game. So you can imagine there's a lot of really cool data here, and it's totally free, which is super cool. So we decided, like, this is awesome. Let's analyze it. Let's look at this, especially since it is time series data, right? You might look at this historical data, and see NFL, oh, this is probably not time series data. It is, in fact, time series data. It is IoT data, essentially. So why, as Timescale, the company, and, with TimescaleDB, our specialty is time series data, we have to analyze this. So that's kind of what we did. And so we're actually going to be posting links in a little bit, but essentially we decided to write a blog post and provide a tutorial for kind of analyzing this NFL data set. And so if you are interested, definitely check it out. We'll add those links later on. And for people reading this or watching this on YouTube, we'll also have the links there. So check it out. Especially since I'm not going to show you how to ingest the data and import it into a database. So that side of things, if you want to follow along, right, you're going to want to go through our tutorial, which shows you how to ingest all the data and actually put it into a database so that you can analyze the data as well. So just some notes. And there is a small caveat with this data set, and that is that this data set, at least for the play information that they provide as part of kind of the data that they provided, it's only showing passing plays. So that's an important note, right? We're not getting all the play information, which is kind of a bummer, but there's still a lot of good stuff here. So that's just a good thing to note, that if you wanted to ask questions about, touchdowns or some other possible play type situations, you can't use this data set exactly, but you still have all the tracking data. So there's still a possibility to analyze a lot. So that's kind of the one caveat, and it is data from the 2018 NFL season, so that's also good to note. And that kind of brings us into, right, understanding the data, which is our second section. And, an important part of understanding the data is knowing the history and kind of knowing, like, where did this data come from, and all that good stuff. So now I'm actually going to switch over to 𝗥𝗏𝗃, which, if you guys have not used 𝗥𝗏𝗃, it's an awesome tool. I am a very visual person, and if you enjoy using Postgres through the terminal, like, that is awesome. Power to you, super cool. For beginners, and probably this stream is a little bit more for people that are just kind of stepping into things. I really enjoy 𝗥𝗏𝗃 because you can have that more visual aspect, and look at the table schema and stuff really easily. So that's this tool that you're seeing is 𝗥𝗏𝗃. So, okay, right here is my database, and we have all the tables that we're going to look at today and use to answer some questions. So kind of to understand the data a little bit, so here, kind of the first table we'll look at, this is kind of the general game information. So we have game ID, which this is going to be an important note. Game ID, as you can see, is related to the game date, 2018-09 September, 9th of September. And since there are multiple games played on the 9th of September, right, you can see all these games. This kind of extra bit is an integer indicating which game, kind of just like differentiating the games that were played on that same day. Then we have the home team, kind of like abbreviations, and the week that it's associated with. So that's cool. Good stuff in there. Next, we can look at the play table. So this is a lot of good information that if you are interested in really kind of digging into the play specific questions, right, this is where kind of like a lot of action is going to go on. So it's good to take note, right? We have game ID again. So kind of right off the bat, we see game ID, and it's, an ID column. So this is going to be an important column in how we're going to tie tables together and join them. So that's a good thing to note. Like, we see game ID again. That's cool. We see play ID as well. We have play descriptions, quarters, downs, yard to go, the possession team. So which team has possession of the ball, which is awesome. We also have play type, yard, line, side, all this good information, which is super awesome and could be really useful. So that's, again, good thing to note when you're kind of trying to understand the data and get a good picture of, what's going on here. And also pass result. That's going to be some important stuff that we look at today. We're going to have some queries that look at pass results because, right, that might be a question you want to answer is like what could go into a completed pass versus an incompleted pass, or a sacked pass, whatever it may be. So then next we have the player table. So this is just information on the players. And so you can see, right, we have a player ID. So this is an ID now that we have associated with a player. So that's another thing that we want to note, keep in the noggin. And we have their height, weight, even birthday, college name, position, and display name. Again, this display name is going to be key, right? Because IDs mean nothing to us. So it's good to know who are these players that are associated with the IDs. So good stuff. But it is also something that and again, I've looked at this data a lot. So of course, y'all who are looking at this for the first time, I'm sure it's a lot to take in. And so that's kind of like what I want to encourage you when doing analysis on a data set, right? It's important to kind of sit with the data, understand how does it tie together. And so one kind of insight that you can realize with this table is that it doesn't actually tell you which player is on which team. So that's something that, is good to know as you're getting to know the data, like, if I wanted to know a question that tied a player to a team specifically, I'm going to have to probably figure out how to tie tables together to do that. So that's something to note. Then we have our scores table. And as you can see, it has the date of the game. We have the visitor team information. So that's cool. The score associated with the visitor team, what they got in the game, and then the home team name and abbreviation, and then the score that they got during the game as well. So that's another cool table. Like if we wanted to compare scores, or who won potentially, and were plays involved, the number of plays involved in, at least passing plays involved in who wins, That might be a cool question to ask. So we have stadium information. So here we have the stadium name, location, surface type, roof type, team name, the abbreviation, and then the time zone. And so kind of looking at this is a lot of good information that we might want to pull on, right? If we want to compare surface type and performance of players on, based on surface type of a stadium, or even the stadium location, right? With American football, right, the NFL is playing across the U.S. So that means that there's a potential, we have a lot of time zones going on there. So that's something to also keep in mind for location of the game, if you want to do stats based on, where's the game even playing at. And also if you wanted to do something, with the turf and things like that. So this is all good stuff. And then the last table, which is, I think, probably the most important table out of this. This is our really heavy time series table that we're going to get a lot of good information out of, is the tracking table. There is tons of data here. If you, I'll break it down. So, right, we have the time. Essentially, right, this is an IoT, these are IoT readings, essentially, right? The players are acting as IoTs, practically, with the RFID tags, which is super cool. So what we have is that at any given time, it gives us the position of, so the X and Y. So essentially what they did was create a coordinate graph out of the field, And so, right, the long-wise is our x coordinate, and then the short part of the field is the y coordinate. And so this is essentially giving us like x, y coordinates for the players at any given time, which that's awesome, right? That means that we could essentially place any player on the field at any given second or part of a second, which is really cool. So there's a lot that you could do with that. S has to do with it's the player's speed at that certain moment. A is going to be the acceleration. Distance is the distance traveled from the previous point of like recording time. So we're going to use that a lot today to answer like more general questions. O is going to be our player orientation. DIR is the angle of player motion. And then the other stuff is kind of more intuitive, right? It's not just one letter, like 3. So the event tells us, like, did something happen, at least according to a pass play, right? We have the player ID of, which player's RFID tag is recording this data. It also gives us their display name. We have their jersey number, position, and so this frame ID, this essentially is breaking up the seconds into like the number of milliseconds that it reads. So what I mean by that is, right, if you look at the timestamp here, we have 1/7/14 and it continues 1/7/14, but these are actually 2 different frames. So it's 2 like different sets of time. So that's kind of how it breaks up our seconds into kind of like further bins that you could potentially play with. So that's something to note, right? It gives us the away, whether that individual is part of the away team or the home team. We see game ID again and play ID, so that's again something to keep in mind. Play direction and route. Okay, so that was a lot. Talking about data, probably a lot of numbers that you're looking at. So now, right, we kind of get a better idea of like, what are these tables? What are we looking at? What are some of the questions that we could answer? And which is like all great, super cool. But before we go into actually answering questions, there is something kind of like a next step that I wanted to go through. And so I'm actually going to go back to the PowerPoint. Dun, dun, dun. Setting up the data for analysis. So, right, we could just jump into analysis and that's all good. You could totally do that. But if we go back to 𝗥𝗲𝗹𝗲𝘃, let's say that you wanted to answer a really simple question. And so, sorry, I always press the wrong thing because I'm used to working on a Mac and this is a Windows machine. Anyone else have those troubles? So, okay. Let's say that I want to answer a really simple question. I want to know for a single player on a single game, how many yards did they run in total over like the entire game, and what was their average acceleration for the game, right? And keep in mind, right, this is not very granular. So if you were really wanting to go into deep analysis, you might want to do like per play or per minute even, but today we're just going to do per game, just kind of for a simple, get you guys used to kind of like analyzing this data and looking into it. So let's say I wanted to answer this simple question. So right, I'm going to grab the game ID, the player ID, display name so we know like who the player is, the sum of the distance, right, that distance column, distance traveled since last point, the average of the acceleration from our tracking table, and we're going to group by the game ID, player ID, and display name, right, because those are not part of they're not aggregated. So if I run this query, cool. It's taken some time. You know, I can take a sip of coffee. All right, so we have a duration of 10 seconds. Now, what if you wanted to build off of that? What if you wanted to grab, then, you know, combine the, you know, take the average of the, you know, yards run of players over one game, right? I would have to call this exact query again and then take the average of this new set, right? That means that every time I run this query, I'm going to get like 10 seconds sometimes. And this is like a pretty, like a good machine. If I ran this, like when running it on my Apple laptop, it took 28 seconds. So you can imagine, like, this could be a huge time suck, you know, and that's not super ideal. So how could we make this faster to make our analysis faster? And this is where timescale functionality really like shines. And that is continuous aggregates. And I'm going to talk about some other timescale functions today just to show you like how fast and powerful they are. Which if you're looking at data and you're trying to understand what's going on, right, you don't want to have to wait 10 seconds every time you want to query something, right? That's not ideal. So what we can do is actually create a continuous aggregate that does this kind of heavy lifting on the tracking table for us, which, you know, if we can do that, we want to do that, right? We don't want to have to heavy lift every single time we want to run something. So here, so for this continuous aggregate, when you're creating one, for those of you who are not familiar with continuous aggregates, right, we're going to use create materialized view. This is going to be the name of our continuous aggregate with, this is kind of like the function that tells, that lets, you know, the system know like, okay, we're creating a continuous aggregate, not just a materialized view. And then as this just then kind of tells it, this is the data that you want to put into the continuous aggregate. So just for the sake of, you know, kind of looking at this data and understanding it, I'm going to run this. And see, a benefit of continuous aggregates is instead of having to run this query every time, it essentially like saves that information for you so that you can just query it directly and it doesn't have to like re-aggregate all this stuff. And so that's like a huge benefit time-wise. So, right, this query looks a little bit different than the previous one, but let's walk through it so we understand it. So I'm going to select player ID and game ID, right? That's going to bucket it so that we know, right, we're setting apart each player per game. So that's important. And this is just telling us the position and the team, the home away team identifier. And again, right, that's going to stay unique to the player, right? A player is not going to change position during a game. And right, they're not going to change the team during a game. So we know that, right, this isn't going to bucket things like more granularly. So it's going to stay in line with that player game kind of like identification. So it's just giving us extra information, right? So now we're getting to time bucket. So this is, again, this is a timescale function, time bucket. It's super useful, especially if you work with any type of time series data, especially like IoT, like if you're dealing with a lot of really granular data and you need to bucket it by time, this function is going to save you like again and again. It's awesome. And so essentially what I'm saying is that I want to bucket the time with an interval of 1 day. So that means like every, right, because naively, and I say that, and you'll know why I say that, naively I assume, right, that a game is played over one day, only one day, right? And that's like, probably that's a decent assumption, right? You're probably not going to play a game between 2 days, right? That would be like 11 p.m. into like 2 a.m. or something. It's a pretty late time. So, naively, that's a good assumption to make. And then, right, the column that we're actually going to bucket on, which is our time column and tracking. If you look back to tracking, right, this is the time column. So we're doing that as bucket, and then this is going to sum the distance, right? So that we're doing the same sum. It's summing the distance over, like we're summing all that distance traveled information. And then we're taking the average, we're taking the average of the acceleration, right? And then we're going to do it from tracking, and then we have to do the group by things that aren't aggregated. So that's kind of what, right, if I when running this query, this is the kind of information that we get. So we get the player ID, game ID, the position that they have, the home away team identification, the time bucket. And again, if you notice, this is from 12 a.m. on one day, to 12 a.m. of the, or 11:59 p.m. That's kind of one bucket, right? And then the next bucket starts at 12 a.m., 11:59, We have the summed yards and then the average acceleration. So cool beans, this is awesome. So we're going to run that. And creating your continuous aggregate does take a little bit of time. But again, you think about how much time it's going to save you after the fact. And so that's kind of like the benefit of setting up a continuous aggregate and doing that for your analysis kind of ahead of time, because it makes querying things just a lot faster and more efficient for you in the long run. So this is a good time to grab a cup of coffee. I promise I'm not a coffee advertiser. I just really love coffee. Or tea. Tea is awesome too. Tea doesn't get enough love, honestly. I love tea. Okay, so we have our query is completed. We have our continuous aggregate, which is exciting. So now, I'll just close that. So now, delete that. So initially, right, if we go back to that previous query, this one that took 10 seconds, right, while I get the other query running, we'll run it again just for kicks and giggles. Which essentially, right, this gives basically the same information as if we were to just select all from, actually I'm going to create a new one so it recognizes, because I like making my life easy. So this way it recognizes the continuous aggregate, which is this guy, our player yards by game. So if I select this, instantaneous, super cool, really useful. Now, one thing that I'm actually going to go into again for setting up our data for analysis, and kind of, you could say that this is also part of understanding your data, right? Going back to our naive assumption that one game is played over, one day, that, for kind of obscure IoT stuff, like this information, right? This is kind of a more odd case, right? It is actually true that some games were played over 2 days. So, and just to show you that, if I run this, which this just counts the number of buckets, time buckets. So it's counting how many kind of like bucketed rows we have for a unique combination of player and game ID from our continuous aggregate. So if we run this, again, instantaneous, because we did this really heavy lifting in our continuous aggregate. We do see that there are some player game combinations that are played over 2 days, time bucketed amount. So this is something that's good to keep in mind, right? For irregular data, you could run into cases where you want to kind of combine things further. And so that's what we're actually going to do today. And just to give you, just for fun, let's see. And actually, whenever you're analyzing data and you're trying to get to know the data, you see like, okay, so we have these unique combinations of player NIDs that are going over 2 days essentially. So what about like how many is that happening? So then what I'm going to do is use a CTE that I'm going to name bucket counts. And so it's just this is the same query that's used to generate this. And this time I'm just going to count, for how many do we have 2 buckets, 2 time buckets, and for how many do we have 1 time bucket. And again, this is like part of the data analysis process. And that's a lot of like what I want this stream to be. And actually, we're going to have a series of blog posts later on that also talks about kind of like more data analysis, like how you analyze data. So this is just kind of like, a fun starter to data analysis experience with TimescaleDB. Okay, random tangents. So, okay, here I see, that there are 1,000 cases where we have, unique player game combinations that are played over 2 time periods. And we have 11,000 where, it's, as we assumed, 1 game is being played over 1 day. And again, because we're dealing with time zones, the dreaded word, time zones, they're the worst. When you're analyzing data, time zones can play into this. So that could be part of why we're seeing these games being played over 2 days, is that, if it was a game played in California at like 8 p.m., for Eastern Standard Time, it would read it as a lot later, if we were binning by Eastern Standard Time. So it's just, things to think about. So, and let's just say, for fun, because this is what I do. Whenever I'm analyzing data, I'm like, okay, why do we have 2 counts? This is weird. Why would we see this happening? I might actually go to the game information and I want to know, okay, what happened in this game? Why are we getting a bucket over 2 days? That's super weird. And so part of what I would do is also kind of look at okay, let's look at the granular data. Let's kind of zoom in and see, okay, what's going on? Because I like to understand, why is this data appearing, unexpectedly? And so just for fun, let's say that, for this count of 2 that's happening, I want to know, okay, what was going on in that game? So I'm going to select all from the tracking table where the game ID is this. So I'm just copying over the game ID here. And then I'm ordering it by time descending just to get some quick information. So, okay, we see that the game time-wise, actually, let's do ascending first because that's more fun. Why not? So if I run this, so the game started at, I'm terrible with military time. 21:29:06. What is that? 9:29? You can check me. Fact check me. 9 or I think it's 9. We'll just go with that. So, if the game started at 9, okay, interesting. So it's 11:11:21:29:06. And, this is the beginning of the game, This is the smallest time period. And then what about descending? Where does it end, And we see it's actually 11:12 at 12 a.m., 12:30 a.m., I should say. So that's why this is occurring, You can see why we got bucketed into 2 different days, because literally the game was being played over 2 different time periods for this time column, So just like fun ways that you can get to know the data. That's, again, just something that I enjoy to do. So it was a lot, I'm sure. So setting up the data for analysis. Now we kind of have a better idea. We understand the data. We have our continuous aggregate set up. So now we can actually get into the meat of things, right? So going back to the PowerPoint, let's actually analyze this data, right? We want to answer questions. Let's answer some questions. That's what data analysis is all about, right? We want to answer questions with data. We want to analyze the data to get information out of it. Good stuff. So let's go back to 𝗙𝗏𝗃. All right, so let's kind of we'll clear our console out. So what kind of questions do we want to ask? Let's say, as a first question, what are the stats on distance traveled by players? So I want to know, what's like a breakdown of the statistics on that sum of the yards run per game across all the players, across all the games. So this is also where, and I'll show the query, because also, right, we have that issue, since we're using kind of irregular data, we have that issue where we're, having 2 counts, or 2 kind of rows representing 1 game player unique combo. And so essentially you'll see on a lot of the analysis queries that I'm going to run through today, I'm going to run this CTE just kind of off the back, which you could make into a view, and that would equally, work just as well. You could just pull from the view directly. So that's totally an option, and that's another benefit of kind of Postgres functionality is, right, I can save that off. But I'm just going to include it in a CTE, so, you do you, whatever you want to do. So here, right, essentially what I'm doing is player ID, display name, okay, so let me start over. So this is our continuous aggregate, right? I want to sum the yards across our continuous aggregate to make sure, right, that we have a unique, 1 row associated with the total yards run and a player game unique combination, right? And so that's kind of what this is doing. So this kind of solves the issue that 2 count kind of brought into play. So that's what we're doing here. And then I'm joining the table on the player table to get the display name of that player. Because, right, if you remember, our continuous aggregate does not have, just to show you, because I am a visual person. So if we go to this and we run this, right, we have the player ID, but we don't have the player name. So that's kind of what this is doing, is that it's joining on that table to get the player name, so we have a little bit more information. So, right, again, just to show you, this essentially is our continuous aggregate, but it kind of condenses it down to solve that 2 count issue that we saw, because games were being played over 2 days. So now we have, right, the player ID, their display name, so we know actually who is associated to that player ID. We have the total sum of yards that they ran for this specific game. Cool. So now I want statistics on this, right? I want to know, like, what's like the interquartile range of how many yards players ran during a game. I want to know, like, the min value, like what player during what game ran the least number of yards, and what player during what game ran the most number of yards, right? This is something that I want to know. So this is where timescale hyperfunctions is like clutch, and you want totally check them out because they are flippin' awesome. Highly recommend. They're super cool. They're really useful. And there's a fantastic blog series that talks about how we created our hyperfunctions and this two-step aggregation method. It was written by David Cohn, who's one of our engineers. He's brilliant, and the explanation is really good. So if you are interested in like how these functions can be so efficient and actually how you can use them in continuous aggregates, which, note, I will be going into creating continuous aggregates with these hyperfunctions so that you can allow for rollups and stuff. That's going to be in a later blog post and probably like a later stream. But so that was a side note. Back to the main note. Essentially, check out hyperfunctions. Super cool. You could learn a lot. It's super efficient. It's awesome. So, now that I'm, not, I'll stop fangirling over hyperfunctions, but they're super cool. So here, Timescale has these hyperfunctions that essentially can grab your statistics super easily. So right here, here's my yards column, and I want to know all this statistical information about the yards column. And so what we do is that this is so it's called an accessor function. Again, look, and there will be links to all of this information in the description. So definitely, come back, check it out, look at the links. But essentially, so this is like called the accessor function. It's and then this is the aggregate inside. And what's cool is that essentially with our functions, when I run this query, this part, which is kind of like the meat, the aggregation, like the meat of this function, is only being calculated one time. But yet I can run, clearly, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different things. And I don't have to do all this reaggregation. Again, super cool how we did this, but it just makes it really efficient. And I'll show you, right? If I run this query, instant, super cool. And so essentially, right, this approximate percentile hyperfunction gets me like the value that would be at the first percentile, or like the 90th percentile. So, and right, for 0.5 for the percentile, that's really just the median. If you're familiar with statistics, like it essentially is giving you, right, and then you can use this 25 to 75th percentile to calculate your interquartile range, which is what I did down here. So it's like super easy and super cool, super fast to just grab all these statistics. And same thing with like tdigest. So this is the accessor function in this case, and then this is the aggregate that happens on the inside. And again, we're not recalculating here because it's the same. We have the same aggregate going on. And so it's just kind of this like accessor function that's being applied in each case. So what does this actually output, right? These are all the values. So values that are below the first percentile are values. So we know like there's probably very, very few people that are going running less than 10 yards per game. And if we look at the 99th percentile, there's very few instances where we're seeing a player running more than 2,885 yards per game. And actually, well, I'll get there later. I'll get there next. Just wait. So much fun stuff going on here. So then, right, we see that the min val of yards run per game is 0. I don't know who did that. But also, that's another question. I look at this statistic, I'm like, what the heck? Who did this? Like, who only ran 0 yards per game? Like, what was happening? Right? That's a question that you could be like, oh, okay, now I know. Same thing for max, like 4,470 yards a game. Like, that seems like a lot. And we'll actually see why. Fun stuff. And same thing with like, we have the mean, like the mean of the yards run per game for a single player is 485. Okay, that's cool. The number of values is how many, how many rows of data do we have in this original query. And then the interquartile range is, this 25th percentile to the 75th percentile, and like the spread of data that exists in that range. So that's the range available from 25 to 75. Cool beans. So now my question is, what is this max value? So like I'm now curious, like what players performed above the 99th percentile, right? Like I want to know who are these players that ran this much during a game. So now I can run select all from, and actually I'm going to just snag this, right? Because this is kind of, and again, another great reason to probably put that in a view or like, materialized view, which is cool. So some yards. Oop. So I want to select all from, this query that gives us that player game unique combination, sum of yards. Probably said that 1,000 million times, so I apologize. But now I want to know where the yards is greater than or equal to this value, right? I want to know what's going on here, like who is performing like this with the number of yards that they ran. And again, I'm showing you this to hopefully inspire you to kind of in your data analysis journey. So if I run this query, you'll notice null. What? Why is it null? You might be asking. What is this player? Well, if you remember from way back in the beginning of the stream, they put an RFID into the football as well. So this is actually the football. This is stats on the football. And if you want statistics on just the players, right, you don't want to include stats on the football. So what we can do, now that I figured that out, like, oh, I'm including, acceleration and yards traveled by the football, which that's probably not what I want to do. So I can come back here and just do, not there, I want to do one above, where player ID, it's underscore, D is not null. There we go. So this is now going to filter out the football instance. Oh, it's ambiguous, my bad. There we go. So now we have a lot better statistics, right? The 99th percentile is 1,159. That's more reasonable. The max val is 1,831. So now if I do this same query, if I want to know who was performing so like running so much during one game, now I can actually see oh right, because this is including, I have to put in the same line here because we're grabbing this thing because I don't want to include the football, so I just do this, so now I run that and bam, we see all of these players, like they ran a lot during these specific games. Kudos to them. So that's, something like another thing that you can look at. Okay. So what about another question, right? We have stats. We have these stats on, and again, another cool thing about 𝗙𝗵𝗱, if I want to have multiple windows, like if I want to go back to the stats and not have to like rerun it every time, I can actually open up another view, like another table view, which is nice. So we have all these cool stats. What about another question? Let's say, it's cool to know these stats and stuff on, a player over one game. Like that's tight. But what about like by position? What if I want to know, let's say the mean and median yards run per game per position? Like what's the layout of like how much people run, based on their position. So I'm going to clear this all out. Boop. So, okay, let's look at this next query. So now, right, we're doing this same kind of like aggregate that we're doing right here. And also note that I don't have to include the like taking out the football in this case because the football doesn't have a position, and so that's kind of like what this guy does down here. But so our stats won't be messed up in that case for this guy. So right here we're going to kind of like make sure that everything, all the bins are correctly counted and things like that. So then my query, I want to know the position which we have in our in our continuous aggregate. So it's super easy. So I want to bin by position essentially, and then I'm going to take the mean of the percentile ag yards. Again, more hyperfunctions and how they're super useful. So we're going to take the mean, and then we're going to find the median using approx percentile. So then we can run this, and then I'm just grouping by the position and ordering by the mean yards. I decided to order by the mean yards. Why not? So if I run this, ooh, I forgot. This is this query, excuse me. This query was grabbed from, anyways, you don't need to know. It just didn't run. So I run the query now and I see, right, okay, the mean yards and the median yards. So this is like cool information also, like when you're trying to figure out kind of more about what's going on, right? You can see that, okay, FS, this is testing my football position knowledge. FS is forward safety. Yes, forward safety. So the forward safety, the mean value is 595, essentially, and the median is 626, right? Immediately, this should indicate, oh, okay, this is probably a skewed distribution, because the mean is far less than the median. So there may be like a lot of people kind of that are not performing, like some people that have it like really small numbers, which is skewing the mean, versus like the median, which is showing like the true middle of the data distribution. So that's, something that you could maybe look into, like, oh, why, who's potentially like affecting this mean, making it so much less than the median in this case. And same thing. So we have all these players. Same thing here. So like the DE, DE, position defensive end. Thank you, Google. So the defensive end, right, the mean is 185 yards run per game, and the median is 33. Kind of flip-flopped, right, of the forward safety. Some individuals that are defensive ends are like super outperforming other ones, right? Because if the middle of the data is 33, but the mean is like 185, there's some probably group of people that are running a ton during a game, and others that are running probably a little bit less. And so that's like another question that you could kind of dive into is like, okay, what's going on here? Why is there such a big difference between this? And so that's another kind of path you could go down. And again, like endless possibilities that you could do with this data set. And really, truly, any time series data set, you can, and just any data set in general, but of course, like time series specifically, like there are so many options that you could go into. Anyways, all good stuff. So, we are actually out of time because we got a little bit of a late start. So probably next time we'll go into more, just like more query possibilities, more analysis. And again, like there are so many things you can do with the timescale functions, and we're going to explore a lot more in the future. So definitely if you're interested in kind of looking at data and really analyzing it and getting into it, and come back because we'll have more, I'm sure. And there's also going to be a blog post coming out later on where we're exploring IoT data some more, all that good stuff. So yeah, thank you guys for coming. Hopefully you learned some things, or if not, you just had fun. So we will see you guys next